Okay, so welcome to the first session of Excel Analytics and Programming. We'll be meeting here every Wednesday for the rest of the semester, unless we have changes, which you'll be notified by email. My name is George Zhao, and I'm a third-year engineering student studying operations research here. And the goal of this course is to give you a sample of some cool things you can do in Excel. And in particular, we're going to learn about functions and programs. And what that does is that gives us a chance to write algorithms, and we can do many cases with those algorithms. So just a quick run of how this workshop is going to run. We'll meet here every Wednesday, and through writing algorithms, we're going to solve the cases that I found throughout my experience with Excel. So what cases do is that rather than learning more of the theoretical side of Excel, which that is one way to learn it, this gives you a practice into how to solve these problems, and you get to see more of the application side of it. There are many ways to really learn Excel. You can pick up a book and learn through the syntax, but from my experience, I feel like the best way to learn it isn't really to learn and memorize the syntax, but it's really to work with them. So that's why I really recommend everyone to bring laptops so you can follow along. But even if you don't have a laptop to follow along, you can still try these exercises later on your own, and just to get a feel of doing it. I'll just quickly show you the website where you can find all of this information if in case you miss it. I've sent you the link for this website already. This might look different later on, but all the files that you need are here. So in addition, so for those who can't come this time on Wednesdays, as you saw, I'm recording this, and this will be put on the webcam, put on online hopefully soon. Okay, so I plan everything out and hope that this will take through the rest of the semester, and that will really depend on the pace of the session today. So you see a mix between cases and tutorials, but honestly, there's very little difference between them. You may be asking how we're going to start any case without any tutorials. Well, cases have really a component within them. Like, even though we're solving cases, you'll really learn how to do it while we do it. And tutorials are, just short teaching points that you really need before we move on to the next point. So throughout all these sessions, I'll be alternating back between this learning slides and the Excel file. So on here, I have really two Excel files that you'll be working with. One is all the blank exercises, which is the file that if you open, don't have much in them. And the other file is the filled one. So when you're working this on your own, what you can do is you can have the learning slides open and then do the exercises on this blank document. And then you can check whether you did it right by looking at the filled document. Think of it as the solution key. So people have asked me about, what do you do if you have a Mac? I'm not a Mac user, but from what I've learned, most of the functions that you'll see here are doable in Mac, but some shortcuts are not applicable. And throughout these slides, I didn't distinguish which ones can or can't be done in Mac, but most of the programs we write and most of the functions that we use can be doable in Mac. A few shortcuts you may not be able to do, but those aren't the main point of these sessions. All right. So does anyone have questions before we jump into the first case? Okay. So we'll start with something that's really simple and it's really understandable, but also at the same time gives us a way to work with some of the important tools for later on. So the first task is filling up a multiplication table. So if you're given, say in this case, 5 by 5, how do you fill the contents of it inside? So you can think of different ways you can do this. You can, manually type them in. But since we're working with dynamic algorithms, we want to think of what's the best way to fill it up. And not only that, but if we were to increase the size of it, what's the best way to maintain this algorithm for later on? Okay, so before we get to this, I'm going to add an additional task. That is, how do we even get this numbers here the way we have? Specifically, if we were only given one side of the number, say in the first column, how do you get the numbers to get on the other column here? And what's the best way to do it? Okay. So for those of you who are following on the computer, we're going to be jumping into the blank Excel worksheet. Okay. So the first thing we want to do is, so we have one side of the multiplication table, and the question we're asking ourselves is, what's the best way to get them on the top row? So the quickest way to select the row of numbers is to use a keyboard shortcut that's Control, Shift, and Arrow. Control, Shift, and Arrow lets you select everything until it encounters an empty cell. So if you start with this cell, the A2, if you do Control, Shift, Arrow, you get to select everything at once, whether there are 5 entries here or 5,000 entries. And this is a really efficient way because you don't have to scroll down all the screen. In one constant time, you can select everything. So now we want to paste this onto the first row, Control C, but what we want to do is to transpose it, which is inverting the rows and columns. And in the PC, the shortcut to do this is Alt-ES, which brings you to this paste special table. Alternatively, you could have right-clicked and selected paste special, but this is one of those short keyboard shortcuts that's really helpful, especially because paste special is one of those tools that are very useful. The options that you'll probably use the most when you're doing paste special is values. You use this when you have numbers that are defined by functions, but you just want the values of them. In this case, we want the values, but we want to be able to transpose. So if we click the checkbox here or click E and hit enter, we were able to get the numbers on the top row. Okay, so now we're ready to actually fill this table.
What's the command again?
It's Alt-ES. Okay, so we have this table ready and we want to fill it up. And we have to think that we want the best way to fill it up so we can expand this later on. Okay, so we're going to do this by using something called fixed reference cells, which you may have worked with before, but here's a quick review of that in one dimension. And recall, we're going to use this in 2 dimensions in a bit. So you want to fix references when you're dragging down formulas, but you don't want the cell that it's referencing to change. In this example, we put a value into the cell B1, and from that we make an XY table with this function. So we're able to get the first value by just typing it in. And if you're trying to do this, one way to have the formula shown is if you go to the formula tab and do show formulas. This is helpful later on when you're trying to dissect what you're doing. So if you are going to type this formula, so in cell B4, you're going to do 1 plus B1, which is the R value, and then multiply by the number here, raised squared. You'll get the right answer, but if you drag down, you see that the reference B1 shifted down as well, which is not what you want to do. You want these B2, B3, B4 to always be referenced to B1. And the way to do this in one dimension is to put some dollar signs before or in the formula. So now you see that if you put the dollar sign in between or before the b and before the 1 and drag it down, it's able to stay the same. And you're able to get this nice function table. So to fix the reference in A1, B2, or any cells, you put the dollar sign before the letter and before the number. This is what happens in one dimension, but we want to see how this can be used in 2 dimensions. Okay. So to do that, we're going to look deeply into why exactly there are 2 dollar signs. And specifically, we realize there are 2 dollar signs because we're fixing the row and the column. So it's 2 dimensions of data that we're fixing. So here, if you don't put anything, you're not fixing either the column nor the row. When you put both dollar signs, you're fixing both the column and the row. And this is more of the elementary tools, but a useful tool is when you only fix one of them. So if you put a dollar sign before only the A, you're fixing only the column A, but not the row 1. On the other hand, if you put the dollar signs before the 1 but not the A, you're not fixing the column A, but fixing the row 1. And this is really the key in creating these multiplication tables or any 2-dimensional data that you want to work with. Okay, so back to our multiplication table. We all know the algorithm in English words about how to input this. For each of these 25 cells, we want to multiply the row index by the column index. And you want to do this for each row, and within each row, each entry within it. So let's see what that would look like once you have the formulas. So this is just manually typing each formula. You know the number here, which is 12, is going to be the product of A4, which is 3, and E1, which is the 4. And similarly, look at this. It's the product of the 4 and the 3. So this is the 3 and the 4. This is the 3 and the 3. This is the 3 and the 5. So the most important thing to take away from here for all the lessons later on is that you want to look for patterns. That's something to always think about when you're working with functions, and especially later on in programs, because functions and programs, which make your life easier, is all about recognizing what the pattern is and how you want to take it. So just look at this 5 data entry. What kind of patterns do you see here? So you see everything on this row 4 is a product of 3 and something else. So it's a product of 3 and 3, 3 and 4, 3 and 5. It's always A4, A4, A4. And then let's look at this column E. Everything here is a product of 4 and something. 4 and 2, 4 and 3, 4 and 4. They're all E1, E1, and E1. So let's see how we really can expand this for the entire table. And here's where you really have to be careful about row, column. Because if you take any row, say in this case row 4, which has the number 3 on the first column, if you take these numbers, if you take this row, you have multiple columns. Whereas if you take an entire column, you have a bunch of rows. So if you want to focus on just one single row, so row 4, if you want to take this row, you're going through various columns. And going through it, you want to fix the first term, which is the A4. But what would happen if you didn't fix any reference? what would happen is that when you drag the formula, it's going to change from A4 to B4 to C4. But you always want A4. So you fix the A, fix the column letter. But you don't fix, well, we'll get to that. So for each row, you see that it's always A4. And you know to fix the A instead of the 4 because the difference between here, and here, these three, is that they're in different columns. And if you were to not fix the reference, the A would change. So on the flip side of that, if you take any single column, say column E, for example, everything here is E1. E1, E1, E1. If you were to not fix the reference, the 1's going to change because 1 refers to the row. It could be E1 here, E2 here, E3 here. But we want to fix the 1. So we put the $sign before the 1. Okay. So what you end up doing is you fix the A before the A4 and the 1 before E1. When you type these formulas in Excel, you first type it without fixing it. You can go back and look at the ones that you need to fix. So the $sign goes before A in A2 and the 1 before B1. At this point, you have no idea if this works. Only after you really drag it can you tell if this worked out. So this is where I'm going to introduce a quick way to paste some formula. You could copy and paste this in all 25, but the best and the most efficient algorithm is to paste the formula down. And one of the tricks is once you have this cell selected, you can see that on the right bottom corner there's a thick rectangle or square. If you double click it, or if you hover your mouse over it, you see a cross. And if you double click that, it's able to paste the formula down the column. This is a useful tool, but it only works if it's referencing a column that's adjacent to the left of it. Which is, in most cases, that's what you'll work with, but realize this does have a limitation. But in this case, since it is referencing column A, it is really adjacent to on the left, so this is able to work. Okay, so we got this part, but we need to do this across the other dimensions. And here, again, if you hover the mouse at the square at the bottom right, you can now drag this. When you drag it, it'll go through all the rows. Okay, so you can tell by just looking that the formula really worked. So I have a lot of stuff on the learning slide. That's for you to be able to follow this by just looking at it. So sometimes I might go through these slides quickly, but they'll be right after what I have said. So we want to think about, how efficient with this algorithm. And to think about that, well, we had a 5x5. It was pretty easy. We could have typed everything out by hand, all 25. But what if it were 50x50? How would this have worked? So the first step, which was taking the numbers and pasting and copy pasting it, that was in constant time because Control, Shift, and the arrow, we were able to select everything there at once. So that was constant. That's good. We want algorithms that run in constant time. Similarly, with the double clicking, that happened in one click. The only thing we did that took some effort, by effort we mean we had to go through the table, given the size of the table, was to drag the formula across the columns. And that depended linearly on the number of columns. But all we had to do was to drag the one column over, and we only have to do this once. So this is a pretty efficient way to fill this multiplication table here. Okay. I'm going to show you another way to paste formulas. As I said, the clicking and the dragging, it works sometimes, but other times you may find other algorithms to be simpler. So I'm just going to fill this back out again for now. Okay. The idea is that when you copy and paste these cells with formulas, the formulas copy with wherever you're pasting. So if you're able to, say, take this B2, copy it, and then you're going to go to the bottom. So you want to go to cell B6. And the quickest way to do this, when you have, especially when you have a bunch of data, is you go to the column A, which has all the numbers, and do the control arrow, which jumps you down right to the entry with the last entry that has a data. And here you can paste the function or the formula, and it'll change because it knows that it's in cell B6. So the way to paste all the formulas in between is to select everything that's in between and then paste the formula. So to select everything, you do the Control Shift arrow again. Now we have selected everything. And to paste the formula is Alt Enter. So recall that the idea of double-clicking this corner worked, but only if it's referencing something in the adjacent column. This idea of pasting the formulas at the two ends, selecting everything in between, and doing Alt Enter, that works for any situation. In 2 dimensions, it still works, but it's not as useful. And to think about why it's not as useful, recall that we need to get the corners of the table. So we need the formula pasted onto here. Okay, we can do that. But now the issue is to get all the cells in between this. And there's just not it's a bit more work to select everything we want just with the keyboard and then hitting Alt Enter. So those are really kind of the 2 ways to quickly paste a formula rather than pressing Control V all the time. Okay, so the main takeaway from this quick intro example of multiplication table is the idea of fixing references. And you want to ask, are we fixing the column, row, both, or neither? And in the next example, we'll see how that can be applied to something that's more than just a multiplication table, because multiplication table is the simplest of the form of a 2-dimensional table. Many times in the data you're working with, you don't just multiply one by the other. So here's a preview into what the rest of these sessions may be about. Everything we did here, we could have done in programming with Excel. So to do programming, we first need the approach. And pseudocode is the term that people in computer science use to describe in words how to describe what you're doing. Well, the algorithm is the same. One thing to take away now before we even do any programming is that the algorithms for doing something by typing out formulas and writing some programs, it's similar. We want to multiply the number from the first column by a number on the first row, and we want to do this for each entry. The only thing different is, of course, the syntax. So in a few more chapters, we'll see this slide again. We'll learn how we're able to do these loops and reference the cells and what all these words mean. But essentially, this is a preview that if you run this program, it will have filled in the multiplication table the same way as we did by pasting formulas using fixed references and dragging to quickly paste the formula. So does anyone have any quick questions before we jump into the very next case, which shows more useful ways to use this function? Yes?
We're using until 2007.
No, it's 2007, but later versions can handle everything it does here. Okay. So the multiplication table is very rudimentary. Now we want to work with something that's maybe more applicable. Okay, so the first task we're given is that we're given this 20 by 10 matrix of random numbers. And if you want to go to the Excel file, so another quick keyboard shortcut, if you're jumping from worksheet to worksheet, rather than coming down here and clicking the right one, you can hit Control and page up or down. So if I want to go to the next page, I can click Control page down and go to the next worksheet here. So this is the 20 by 10 matrix we're talking about. All of these are random numbers between 0 and 100. We have 10 columns and 20 rows. So the first task we're given is that we have a bunch of integers here on the bottom. We want to calculate the nth percentile for each column of numbers. So here are the numbers. So here we want the 20th percentile of the data in this range. We want the 35th percentile of this column here. And moving across, we want the 35th percentile of the numbers in column C here. So how these cases will work is that every time we need to do something new, we need to use different new functions. I'll introduce the syntax of it here, and then we'll directly apply them into the Excel document that we're working with. So for this task, we need the percentile. And in Excel, this is the syntax for that. You open all the functions with an equal sign, type that in, and this function takes in an array and a k. An array is just simply a list of numbers. So B1 through B20 is an array, and k is a number between 0 and 1. So here, this is the array, and this is k. This would give the 75th percentile of numbers from A1 to A10. Okay, so here then, we want the 0th percentile of the numbers in column B. And you can use the Control-Shift-Arrow method again here, comma, 0. But it's actually, remember, the k takes in a value between 0 and 1. So we want to convert everything into decimal. So we'll do that by just dividing it by 100. Okay. So this just means that 24 is the minimum number in that in this stretch of numbers. So let's look at this. So percentile B1 to B20, and k is A23 divided by 100. It's right, but you can envision that we want to paste this formula across this entire table here eventually. So what do we need to fix? So again, to think about what to fix, think about what would happen if you didn't fix anything. If you were to drag this down, and you can see what would happen here, you see it changed from B2 to B21, which is no longer the data set we want to work with. We really wanted to keep B1 and B20 all the way down as we go through these numbers here. On the other hand, A24 is good. We still, now we want the 20th percentile, so we want this 20. So what we needed to do in going from here to here is that we needed to fix the 1 and the 20. So if you jump into your formulas, put the $sign before the 1 and the 20. This will take care of it going down here. But what about going to other columns? If we didn't fix anything and we drag this one cell over, you see now C1 and C20, that's good. That's the stretch of this numbers. But now it's referencing B23 as the K value. So now it's giving us the 24th percentile. We really wanted just the 0th percentile. So going from here to here, we did not want the A23 to change to B23. So we're going to fix this A. So quick look at this again. So we're fixing the 1 and the 20 for the data and the A before the A23. Recall for the multiplication table, we fixed for the first entry, we fixed the letter. In this case, the first thing we put in, we fixed the number. That's not very significant. It's just the fact that the syntax of the percentile required us to put in the numbers first. So don't think about which one comes first, which one comes later. Think about what it is that we're fixing. So once we have this, we're going to use the same idea that we did on the previous case. If we double click this corner, it goes all the way down here. And then immediately, while this is still selected, drag everything over, and we have all the data we need. And the thing that makes this dynamic is that if we were to change these numbers here, these functions would calculate the new values instantly. So this is what we always want to think when we are writing a function. First, how easy it is to apply to all the data here, and then how usable it is when the raw data changes. So here, this entry was able to update automatically after the raw data was changed here. So while we're going through the formula, we ask ourselves, do we fix the row, column, both, neither? That's a question you always ask when you have to fix some references. For this case, remember, it was the 1 and the 20, so those were the rows we need to fix. And this was the column. Okay, so taking this data, now we want to do some more calculations, and we want to work with more functions that give us some error trapping or conditions trapping. So at the bottom of the sheet we've been working with, you see here percentile rank, and these are a bunch of numbers from 0 and up to over 100. So we want the percentile rank. So it's asking, how would the number 0 fit into this number? So would 0 be the 20th percentile given these numbers? Is 12 going to be a 25th percentile in these numbers, or is it going to be a 50 percentile? Like, how does these data points fit in within the data we have? And the function for that is percentile rank. And the syntax is really similar to the percentile. You want the array of data you want to work with, And now x is simply now the number that we're testing to see how it fit in. What's different about this is that if it's out of range, it's going to give us an error message. And this is where we'll jump into error trapping in a bit. So filling this up is very similar to filling the multiplication table and filling these tables. Essentially, we have the very same formula. So it's percent rank, and for array, it's the same B1 through B20. And for x, it's A32 now. It's the number on the A column for the row. And similarly, we want to fix the 1 and the 20, because when we go from B32 to B33, you see 32, 33, the row number changed, B1, 1 and 20 to stay the same. So that's why we're fixing that. And over here, we want to fix A, because in going from here, cell B32 to C32, we still want to keep referencing A. We don't want to change to B. Okay, so it's an error, but we're gonna paste this formula anyways. Okay, so this did what we told it to do. It's here 12 is NA because 12 is smaller than the smallest number in this column of numbers, which was 24. Similarly, 104 is NA because it's out of range. So sometimes this would tell you everything you need, but suppose you want an output where if it is out of the range, you want to actually say out of range rather than having these NA with these green marks on the side of it. So this is where error traps comes in. Okay, so error trapping is thinking, if something happens, what do you do? And Excel has a function called if that takes in these parameters. It takes in a condition. Conditions are something that's going to return true or false. They're binary. And then if it's true, it's going to display whatever you put in here at second. And if it's not true, it'll output something here. So in this basic case, 1 equals 1 is going to return true. So it's going to return what's right immediately after it, which is yes. 1 equals 2 is going to give you false. So it's going to jump down to the very last thing. So in this example, which I did not include in the worksheet, but say you want to test whether something is divisible by 11. Otherwise leave it blank. So this is testing what's the remainder after a number in cell A1 is divided by 11. If you had put in 22 modulus 11 is 0. If you put something like 24, it'll give you 2. That's the remainder. So here, if mod of A11, if A1 by 11 is 0, so if A1 is divisible by 11, you want to display what the A1 value was. Otherwise, leave it blank. So the idea is that you can have if statements within if statements. Here it's showing that, if there's 24, it first tests if it's divisible by 2. If not, it immediately jumps down to the statement here and display not divisible by 2. But if this condition equals true, you go into what's here, which is another thing of itself. So if you jump into this statement, it's going to test if it's divisible by 3. And if it's also divisible by 3, well, it's going to be divisible by 6, because anything that goes into here it's already divisible by 2. So if he fails the 3 test, it'll just say it's divisible by 2. So this is just to show how you work with the if function, which is the basics in whether you want to test for conditions or just whenever you have to display different things depending on what something else is. But what we want to do is work with something called if error. And it works similarly, but slightly different. If error takes in 2 parameters, the normal value or what you really wanted this cell to display, but what happens if this normal value you want to display ends up being an error? In this case, anything like NA or other types of that. So we want to put that error trap within here. We don't want this pound NA output. We want to say that if this gives an error, we want to say out of range. So when you're using a function, Excel's good in telling you what the syntax is. So here it says if error value, comma, value if error. This is saying if there's no error, you're going to display this percent rank. But if that percent rank returns an error, you want to jump into what's after the comma, which is out of range. So now you see that it'll say out of range. So when you make a change like this, you want to apply it to the whole table. So we're going to do the same thing of dragging the formulas. So now instead of saying NA, we can have it display anything we want with if there's an error. So you're probably thinking, what's the difference between if error and this if thing, which sounds more basic? Well, logically, what we did seems like this. So what we did was this if error. Logically, it was something like this. If this percentile rank, percent rank, give us NA, you want it to display out of range. But the issue is that you cannot compare something to NA. Excel's going to automatically give you an NA. So if error is the only way to trap something that's going to give you an error. When you use if, you want to trap for some conditions. Like if the sum is greater than 1,000. You want to use if error when you're using functions like percent rank that could return an error. And if error is also much cleaner, because if you're using if, you always have to double type this. So suppose in row 39, we want to display the sum of rows 1 through 10. Okay. So suppose here, so suppose here we want to have the sum of the B1 through B20, but if it's less than 1,000, don't actually say what the value is. Just say it's less than 1,000. Otherwise, say what the thing actually is. So here you would be if sum of B1 through B20 is less than 1,000. And if it's true, you want to display less than 1,000. If not, you want to put the value. But there's no way to reference what you typed in the first part of this equation without typing it again. So in this case, it worked because it's greater than 1,000. So if, or in functions like if and if error, they are trapping for something cumulative. Like you're taking the sum from 1 to 20, and if that sum is smaller than something, you can display it something different. But suppose you want to have a condition on each of this input you wanted to have. So for that, you're going to have to use a different function called SUMIF. So here, the idea to take is that we want to condition each entry that we want to do. So an exercise is, in row 40, this should say 20 here, so we want to sum the entries only if the individual entry is greater than 70. So we want the sum of these numbers, but only if each of them is 70. So we would disregard these ones, but add 80 plus 78 and so on. Using the sum function, or even using the if, we wouldn't be able to do that because we want to condition each entry that we put in. So whenever you get to type this formula, Excel's going to show you the syntax here again. And so for SUMIF, we want to range a criteria, and the what's in the bracket means it's optional. So for here, we want to SUMIF the range that we've been working with, but only if each of them is less than, or let's say greater than 70. So this is the sum of only the terms that are greater than 70. So in the section where they made us type in a condition, conditions are inequalities, or they're anything that's going to give you whether it's true or false. And you put that within quotation marks. So the example we worked with was something like this. Greater than 70 would just be them illustrated with greater than 70 within the quotation mark. Less than, we can have equals, greater than, not equal to a certain value, greater than equals, or so. So in this case, it was greater than 70.